In this video, I'm going to be describing how to find intercepts algebraically. We're going to find x and y intercepts using an algebraic method. To do that, it is most helpful to put an equation in general form, although not necessary. But here is our general form. If we have a coefficient or a number in front of x and a coefficient or a number in front of y set equal to a number that doesn't have a variable, then this is called general form. So given an equation in general form, this equation is representing a line. We can find the x and y intercepts algebraically by using the following methods. To find the y-intercept, we learned in previous lessons that the x value is always 0 if I'm on the y-axis. So I can use that to my advantage. I can set my x variable equal to 0 because if I know that I want to find a y-intercept, my x value will always be 0. So set your x variable equal to 0. That will cancel that term and we'll just be left with the y term, and we can solve for y to get our y-intercept. So to solve this equation, 4y equals 8, you could divide both sides by 4 or multiply by 1/4 and get a y value of 2. So for that equation, if x was 0, y was 2, and that is our y-intercept value. Similarly, we can do something with the x-intercept. For x-intercepts, the y value is always 0. If I'm on the x-axis, I haven't gone up or down. So my y value is always 0 for an x-intercept. So we can use that and set our y value equal to 0 and solve for x. So if I cancel my y term here, then I'm just left with the x term and I can solve for it. So solving negative 2x equals 8. I can divide both sides by negative 2 or multiply both sides by negative 1/2. And we get our solution is x equals negative 4. So if my y value was 0, my x value was negative 4, and that is our x-intercept location. So now I can use those two intercepts. I can plot those points and connect the points to draw a line. So that's what we'll do in the next example. We'll find the x and y intercepts, and then we'll actually draw the line by connecting those 2 points. So this time we're given this equation in general form again. I'm going to solve for the x-intercept. So I'm going to say that y is 0, cancel my y term, and solve for x. I can solve this 2x equals 18 by dividing both sides by 2 or multiplying both sides by 1/2. So we get x equals 9. So if y was 0, x was 9, and that gives us our x-intercept. On this side, I'm going to solve for the y-intercept. For y-intercept, our x value is 0. I'm going to cancel that x term and then solve for the y term. So negative 6y equals 18 can be solved by dividing both sides by negative 6 or multiplying both sides by negative 1/6. And we get our solution, y equals negative 6. So if x was 0, y was negative 6, we know that's our y-intercept. So now I have 2 points that I can plot and connect. I'm going to plot 9, 0 for my x-intercept, and I'm going to plot 0, negative 6 for my y-intercept, and then just connect those 2 points to draw the line represented by that equation. One more example. What if it's not in general form? It is possible that we could just use the same techniques, substitute 0 for x and solve for y to get the y-intercept, or substitute 0 for y and solve for x to get the x-intercept. It's not necessary that we convert it to general form. It just makes it a little bit easier if it is in general form. But it is extra steps sometimes to get it to general form. So that's up to you, whether you want to use extra steps to put it in general form or use extra steps to solve for your intercepts. I chose to put it in general form in this example. So to do that, I just need my x's and y's on the same side. So I'm going to subtract my negative 1/2 x and move that term to the other side, and then put it in general form order. And now I can solve for my x-intercept by setting y equal to 0, canceling that y term, and solving for x by multiplying both sides by negative 2. So my x value is 8, given a y value of 0, that's my x-intercept. Similarly, we could solve for the y-intercept by setting x equal to 0, canceling that x term and solving for y. And so here would be an example of why that general form is so nice, because once we take care of that x term, we're already set up for the solution of y. So our y-intercept was -4 given an x value of 0. So now we got 2 points. We can plot them and connect them to draw the line of this equation. So there's how we solve for x and y-intercepts algebraically.